about to change your life. I am Stephen Hawking, and I'd like to give you a glimpse of your future.
Wow!
In this series, 5 top scientists will investigate game-changing innovations.
This is pretty mind-blowing.
The shockwaves of progress are heading your way. We'll show you how you'll be safer, play harder, connect faster, live longer, see further, and get smarter. With the technology at our disposal, the possibilities are unlimited. So welcome to the science of the future. We have attempted to remove ourselves from nature, but now we are beginning to look at the natural world from a new perspective.
Alright, here we go.
Our 5 scientists are going to investigate how some of nature's most ingenious solutions are inspiring groundbreaking innovations that will shape the world of our future. These megatrucks can move vast loads, but not always to where we need them. We still have to rely on human power to carry things where transporters can't go. Engineering a truly all-terrain machine is a particularly complex challenge. Can it be done? A radical solution is in the works outside of Boston, directly inspired by nature. RT Brass Art is about to test out a go-anywhere mechanical packed horse.
There's one invention that shaped our world more than any other. This, the wheel. Yet half the Earth's surface is still inaccessible to land-based vehicles, even the most rugged off-road versions. The most sophisticated modern vehicles can't match the versatility of nature. But even a horse can carry only a fraction of the load. If we had something that could combine the all-terrain capabilities of a horse with the rugged reliability of a machine, it could change how and where we lived on our planet. This is LS3, the world's most advanced all-terrain robot. Powered by advanced hydraulics and computer algorithms that use sensor data to determine motion commands, LS3 is state-of-the-art. It's the brainchild of scientists at Boston Dynamics, the culmination of years developing robots.
There's a total of 12 actuators, which are like the muscles, that are being controlled by a computer that's on board, which is like the brain. We have a control algorithm that's causing it to walk and step and balance as it goes. And the control computer also worries about the traction of the feet on the ground and whether there's slipping there is, and it coordinates the forces and the motion of the legs in order to accommodate the variations in the terrain.
The onboard computer calculates adjustments 1,000 times a second and sends instructions to the actuators in its legs to continually correct its movement.
This is difficult because it's going downhill. You can see the feet slipping. You can hear it revving its engine because it needs more power to react to the slipping. It keeps its balance.
The gyroscope helps it maintain balance in all kinds of conditions: sand, snow, water, even a muddy slope.
The power for this comes from an engine that's in that box. The engine powers a hydraulic system that goes to these actuators These actuators are like your muscles. They're able to push on the joints on the robot. This is the actuator. These are the hydraulic supply to the actuator. Down here, there's a computer, which is the control computer that reads all the sensors. It's got a laser rangefinder that gives a 3D measurement of the shape of the terrain.
A muddy slope is hard enough. But how will LS3 cope with an uneven pile of rocks? It cleverly adjusts its height to suit the terrain and places its feet in just the right way to keep going. All decisions are micromanaged by its internal systems. At one point I thought it was going to go down, but it just corrected itself, got its balance, off it went. I think it could probably cope with anything if it could cope with that. Amazingly, it can also respond to the human voice.
LS3 power on to turn it on.
I'm now going to take command of a giant robot. Not sure if I'm ready for this. LS3, power on. That is so cool. LS3, get up. LS3, follow tight. LS3 uses laser technology to track reflective markers on my backpack and adjust its steering to follow my path. It's actually really scary having this robot behind me, but it's also very, very cool because I'm talking to it and it's doing what I tell it to do. LS3, sit. Its codename stands for Leg Squad Support System. It's now under trials with the US Marine Corps. Able to go anywhere a soldier can, LS3 can carry up to 400 pounds of equipment and enough fuel for a 20-mile mission. It's part of a new breed of biologically inspired robot.
Designing a machine that can bear heavy loads and then navigate across harsh terrain by reacting like an animal is a technological triumph. If they can mimic quadrupeds, how far can their world-leading engineering and software programming skills improve on robots that operate with just 2 legs?
It's taken millions of years for us to evolve into creatures that can walk, run, jump, and climb. Balance. Something we take for granted, but it's actually a very complex skill. So engineers have taken on an enormous challenge to build a walking biped that can shift its weight from foot to foot. This is Atlas, Boston Dynamics' humanoid robot. Right, what do I do?
Well, I'd like you to come stand on 1 foot up here.
So who has the better balance? Me or the robot?
Yeah, so you're going to put these on.
Blocks my vision.
That's right. And we're going to bang this 20-pound medicine ball into you, and we'd like you to stay on 1 foot and try to stay balanced.
Okay.
Okay?
Okay. To stay upright, I instinctively turn my ankle and move my arms and upper body.
There you go. Good.
It's this natural behavior that technicians have built into Atlas. An onboard computer should detect a loss of balance and move its arms and torso to compensate. But will it work? Turns out, I've been beaten by a robot.
When the ball hits it, it detects immediately that it's falling. It starts to throw its torso and its arms and even its leg around.
With few of the frailties of human beings, it's better equipped to go into danger zones, like nuclear accidents or earthquake disasters. It's got powerful arms for heavy lifting, and a head packed with the latest range-finding laser technology. Atlas is already impressively versatile, like its 4-legged cousin, LS3. One day, big and small robots like these could be helping us with everything from emergency situations, fighting fires, disaster relief, to maintenance and cleaning in our homes, or even carrying our groceries. LS3, follow on. LS3 began field tests in 2012, while Atlas was given its first press demo in summer 2013.
Biomimetics is driving the expanding world of robotics. Machines with jet-like acceleration, or the aerial agility of a seagull, have recently been developed too. And by 2017 the industry as a whole is forecast to be worth nearly $50 billion. But it's not just machines that are being inspired by animals. Things we use every day are being transformed. When I was young, I loved taking things apart to see how they worked, but gluing them back together was often a problem. Enter the gecko. Over 10 years ago, scientists unlocked some of the secrets of its remarkable adhesive capability. Since then, several teams have been looking for a way to synthetically replicate this commercially. Will they succeed? The holy grail of the adhesive industry is a powerful bond that can be removed without leaving a residue. The adhesive properties of gecko skin were first replicated by a team led by Nobel Prize winner Andre Geim. They created synthetic tape that copies the microscopic hairs on gecko toes, but fabricating it on a large scale proved elusive. Now, researchers at the University of Massachusetts, Amherst, are attempting to take the idea further. Chris Elias investigates their progress.
This is a polyurethane adhesive. It's been a staple in construction and DIY for years. It'll stick anything together, but it's really messy, really smelly, and it gives off toxic fumes. It's also not reusable. For now, I'm going to check out a different option. One that doesn't give you a headache from the fumes, or take a day to dry. Two very different kinds of scientists have put their heads together to come up with a new form of adhesive.
To make a viable product that mimics the gecko's extraordinary ability to apparently defy gravity, they needed more detailed knowledge of gecko physiology. With that, they're now developing a new adhesive tape, a small strip of which, they claim, can stick 700 pounds to a wall and then peel off, leaving no marks.
So, you're Mr. Gecko?
I am the Gecko Master.
The Gecko Master, excellent. Duncan Urshik has spent over 20 years studying geckos.
Yeah,
they're amazing.
It's an amazing diversity.
Wow.
And we actually have geckos here from all over the world. This is a Phelsuma gecko from Madagascar. They have really strong toe pads. They can really actually carry physically about 2.5 times their body weight and run straight up smooth surface such as glass.
2.5 times. So for a 200-pound person, that's like 500 pounds? That's about 500 pounds?
That's about right.
So can we watch this little guy? How does he run up?
Well, let's put him on here. And this is just a sheet of glass, so we're going to put him up there, and he's going to use his toe pads. He's going to be able to climb up very easily. You actually notice when he climbs that he's going to put his toe pads down, and he's going to unpeel them.
People often assume that the gecko must secrete some kind of glue to stick to these surfaces. But amazingly, they leave no residue. What's really happening? How does this adhesion work?
So the toe pads are creating a very, very intimate contact with the glass, and the way they're doing it is if you look the foot under something like an electron microscope, there's lots of little miniature little hairs. They're called setae.
Duncan explains that each setae has hundreds of nanopads called spatulae. They are so small, they actually interact on a molecular level with the surface. But Duncan has discovered that while this gives the gecko its adhesion, it's only half the story of how the gecko stays so firmly attached.
These geckos have little stiff tendons in their toes. They're attached to very soft, compliant material like the setae.
And that's the breakthrough discovery. It's the interaction of the tendons beneath its skin pressing down on the microscopic hairs on the outside that maximizes the surface contact of its toes and gives the gecko its remarkable adhesive qualities. This new understanding is what's behind the revolutionary adhesive fabric being developed in another part of the campus, Gexskin. The main man is Al Crosby, who is using new biological knowledge to engineer a real-world product.
Hey, Chris.
How you doing?
Good to see you.
Good. So I was just over at the biology side of the team, talking to Duncan, and now I take it this is the engineering side of things?
Yeah, this is where Gexskin is made.
So could you give me an idea of how what he told me about the gecko is actually being applied to make this material?
The key thing here is you have to think about it as a whole system.
Okay.
It's really simple, actually. We take a strip of fabric and we coat on some polymer.
The polymer acts like the gecko's microhairs, while the stiffer fabric acts like the tendons.
You want to test some of this out?
Sure.
Maybe you want to start with this small guy here. So it's pretty easy to apply.
Okay.
Just like you would a normal kind of adhesive or tape.
Right.
Okay. Then you can tug on it. Pulling down is
and then
really
get it
small.
off. Right. But as soon as I go like this,
Comes off
very easy. Yeah, there's nothing left there either, right? Very cool.
Very zero force.
How many times can I do that?
Hundreds, thousands of times.
The gecko's other evolutionary wonder is that their tendons also enable them to curl and uncurl their toes when running, up to 15 times a second, to attach and detach instantly. Now I really want to see if it can hold all 180 pounds of me to a sheet of glass. For safety reasons, I'm being replaced by a set of gym weights. So this chain is just for security then? Oh yeah?
Yeah, chain is just for safe.
Load it. Now give it a go. This is 180 pounds. This is as much as me. Now we're really putting it to the test here. There it is, right? This chain's not taking any of the weight. It's all the Gexskin.
That's right.
That's impressive. 180 pounds.
So on a path like this, we actually probably get up to 700, 800 pounds. But we'd have to go elsewhere on campus in order to see that.
So I had a good chat with Al, and he showed me Gexskin, gave me a bunch of demos and so on, but all in the lab. I thought it'd be fun if we could bring it out here and actually see if we could move this truck with it. What do you think?
Okay. I think we should give it a shot.
To pull this 2-ton truck, we won't need a tow hitch.
All right, Chris, so this part's for you.
Great, thanks.
I'm going to go steer the car.
You got the hard job, right? All right, so we're going to put this thing in neutral. We've got the Gexskin attached, and we'll see if we can move this truck. You ready? I hope he has the handbrake off. I can't decide what I'm most worried about, my back or the paintwork.
All right, Chris. Keep going. Yeah.
Here we go.
Pull that car.
That's right.
Keep it up. Pull that car.
I think it's done. We proved our point.
Yes.
And not a mark left behind. We've seen all the way from the conception of the idea, applications in the lab, to this extremely scientific experiment.
Extremely scientific.
Highly controlled.
Yes.
So what do you foresee as the future of Gexskin?
Well, Chris, as you can imagine, we've had a lot of companies approach us, from very small to very large, and we're working on commercializing it and hope to have our whole range of products about as early as a year from now.
Tape that can be reused thousands of times over. That's made from inexpensive materials. Very cool indeed. What I find really fascinating about Gexskin is how it represents this interaction between biology and engineering. So they were interested in adhesives, and they had some ideas about how those worked, and actually went to the gecko and found that those principles they discovered were realized by this animal in a very unique way.
I can see many applications for this, from surgical tape or hybrid tires to everyday uses such as hanging the nameplate to my office door. Maybe one day window cleaners will be clambering up skyscrapers like real-life Spider-Man. But I'd like to see a little more testing before I use it to stick my prized Simpsons memorabilia to my wall. There's one scenario which all the glue on Earth won't help us solve. We are under threat from very large asteroids. Once again, the natural world is coming to our rescue. We are training astronauts to intercept them, in a mysterious place right here on Earth. On February 15, 2013, a fireball pierced the Earth's atmosphere, releasing 30 times more energy than the Hiroshima bomb. One day, we may be struck by the big one. Fortunately, some wise folk at NASA have over 1,000 potentially hazardous asteroids under surveillance. What I want to know is, what are they going to do now? On the west coast of Canada, there's a man helping NASA's Armageddon avoidance planning. Daniel Kraft is in Vancouver to investigate.
I'm told a small harborside workshop may play a key role in protecting us from disaster from space.
Phil Newton is a deep-sea diving pioneer.
Great to meet you, Phil.
Nice to meet you.
Phil has spent 40 years creating deep-sea suits and submersibles for exploring the ocean depths. The Deepworker 2000 is a one-man sub that can go to twice the depth of the Empire State Building, and the design has given NASA a light bulb moment. Because the ocean is as close as it gets on Earth to the weightlessness of space.
So, Phil, what would NASA want with a small submersible like this one?
That's a very good question, because you'd think that by definition, outer space and inner space, and this would be as far apart as it could possibly be. But the technology overlap is incredible. We've trained astronauts now, both US and Canadian, to be a pilot of these little subs, and they use them as simulators.
NASA has used underwater training for its astronauts since the Apollo missions. They can rehearse the conditions of zero gravity in space because divers can achieve neutral buoyancy, the seemingly weightless state between floating and sinking. But NASA's grand plan to land on an asteroid needs a craft to practice on, which is where Phil's sub comes in. He's designed it to have neutral buoyancy. And just like a spaceship, the Deepworker uses thrusters to propel it forward and directional thrusters to change course. It's not exactly like zero gravity, but it feels similar because the drag from the water works against inertia and slows down heavy objects. It's the best substitute we've got.
We just finished a project this last year. The idea is that the astronauts would fly in the sub, mounted on the outside, to a fake asteroid that they put down the bottom of the ocean off the coast of Florida. They would then come off the sub and drill into the asteroid and anchor the sub or anchor the lander. So it was great. It was a great project, and the astronauts loved it. They just thought it was terrific.
So NASA's not just doing the training and simulation. Using these submersibles, they're actually able to develop the procedures to maybe land on an asteroid in the future.
Absolutely right. That's exactly what they're doing, and that's what they've hired us to do.
Until recently, NASA's official advice in the event that an asteroid hits Earth is to pray. I'm not kidding.
Now it's my turn to do some prayers. I'm going to test out the sub to see how effective it is.
It's a bumpy trip. You're not going to enjoy it.
I've flown F-16 fighter jets, but I've never tried to land on an imaginary underwater asteroid before.
I have experienced zero gravity in a plane, and let me tell you, it's pretty amazing. I did it because of my interest in space travel. Life on Earth is at risk of being wiped out, either as a result of our own mistakes or a cosmic catastrophe. I believe we won't survive another 1,000 years unless we find ways to expand our civilization into space. So, I'm really hoping Daniel's first deep ocean space flight doesn't end in disaster. In the face of mass extinction from an asteroid impact, NASA has hatched a cunning plan. Astronauts will stop these celestial time bombs in their tracks. Exactly how is still to be determined, but an option is being considered that involves landing on one. Daniel Kraft is undergoing training as if in space at near zero gravity inside a deep-sea submersible.
I'm about about to find out what it takes to pilot a vehicle to a specific landing spot in near weightless conditions. Jeff Heaton is my instructor.
So the simulating long-duration spaceflight, and these are their underwater spacecraft.
That's essentially what they're using them for. We launch these from the surface with astronaut pilots, and then they interact with the people locking out from the habitat.
How do we steer the sub?
This is pretty interesting, a little bit of a departure from other standard manned submersibles. We fly this vehicle with our feet, so it keeps our hands free.
The pedals point the sub?
The right pedal will control your horizontal movement, and the left pedal will control all your vertical movement. Wonderful. Okay, so now we're going to test your horizontal thrusters. All the way. Push her down all the way. Okay, good. There's your elbow extend. Okay.
My greatest concern is what happens in an emergency.
The pressure hull with you in it and all the life support attached to it can jettison from the under chassis. It's a bumpy trip. You're not going to enjoy it. Jettison that.
It reminds me of the Apollo Lunar Lander Module. I now understand why NASA sees the sub as a good training device for space exploration.
So this is pretty exciting. We're going to be craned up into the water. So, it's a different perspective.
Wow, here we go. We're diving to the underwater regions of Vancouver Harbor. There we go.
Alright, so I'm in command of my own personal submarine here. I've got my control systems working, my life support is good, and we're ready to go for a mission. It's very similar to my experience in flying a small airplane, or in the case for NASA training, like flying a spaceship, because unlike when an object's in weightlessness, or in this case underwater, as you enter inputs, you'll have momentum, you'll keep moving. Pretty much got the hang of it.
And Deep Worker 6, please verify both scrubbers on and blowing.
Roger that.
Used on the shuttle and space station, scrubbers remove carbon dioxide so I don't rebreathe toxic levels of my exhaled gases.
Okay, I've got the thrusters on, I'm moving forward, you're going to move forward.
The harbor is 40 feet deep here, and visibility has suddenly reduced. I'm completely relying on my instruments to stop me from crashing into the seabed.
I'm going to look for my landing spot here on my asteroid, and hopefully bring us in for a nice soft landing, because it's a long way up and I don't like swimming in cold water.
Visibility is now next to zero, so my final descent has to be really slow. Touchdown on this substitute asteroid.
That's one small dive for man, or for Daniel. One giant wet leap for mankind. Forgive the bad pun. It's these sort of little steps that we can learn in underwater submersibles that can translate actually to big leaps in human exploration of space and beyond.
My mission is over. Time to go home.
When we come up, it's been really fun to fly this. I'm almost sad to leave underwater space. Here we are back in the moonlight. Amazing.
Around 45 NASA astronauts have completed deep water training, and the aim is to commence asteroid missions in 2025. Let's hope that before then, science can help us figure out an effective way to divert any asteroid that might be on a collision course with Earth. Of course, there are numerous other hazards that science is helping us prepare for. For instance, the threat of a devastating pandemic. Fortunately, scientists think they have a plan for that too. But, and it's a big but, it involves re-engineering one of nature's most feared organisms. A virus. So that it fights on our side against pathogens. Ingenious or plain crazy. My father was engaged in research. He used to take me into the insect house where he kept mosquitoes infected with tropical diseases. This worried me because there always seemed to be a few mosquitoes flying around loose. Back then, if you contracted a dangerous disease, you could die before medics found out for certain what it was. Today, diagnosis can still take too long. It can take days between a suspected outbreak and a positive lab report. And in that time, an infection can spread like wildfire. What we need is a way to instantly identify these pathogens so we can stop them before they get to us. In Birmingham, England, an ultra-fast detection system is undergoing trials. Jim Al-Khalili has bravely volunteered to put it to the test to uncover if it really can improve our chances of survival.
Outbreak. A deadly infection claims its first victims. Cause unknown. A new strain of virus, a lethal bacterium, even bioterrorism. There's a race to find the source, identify the threat, or risk an epidemic. This isn't fantasy. It could happen at any time. The problem is finding the cause of an outbreak can take up to 2 or 3 days, and some of these bugs are deadly. Some microorganisms mutate at alarming speed. In the war on bugs, the enemy has the upper hand. By working with one of nature's predators, biotechnologist Professor Tim Dafforn and his team may have found a way to turn nature against itself.
So, Tim, the challenge, I guess, is to detect pathogens, so any microscopic organism like bacteria or viruses that cause infection, as quickly as possible.
Yes, and to do that we take our inspiration from biology. So life's been on this planet for billions of years, and during that period it solved most of the problems which are currently facing man. So we look back into biology and attempt to use biology to speed up this detection in a really big way.
The hope is that by adapting nature at the nanoscale, they can find a solution for a serious human problem.
We work on a virus, and our virus is M13. So M13 is a long, thin virus, and it's completely inert. It doesn't cause any disease in man, unlike the viruses we know about, like HIV and hepatitis. Now, we've engineered that virus. So we've added another part of biology. This is an antibody, and an antibody is part of the natural immune system in human beings that hunts down bacteria. So what we can do is we can add that to our virus, and we now have a virus that can hunt down bacteria. When it hits the bacteria and finds the bacteria, it wraps around the bacteria, and we know that there's a pathogen there.
So you're basically re-engineering an otherwise useless virus and turning it into something useful, a heat-seeking missile that seeks out these pathogens, wraps around them, and you can instantly see that that's happened.
Absolutely. I mean, we can do this test in seconds. It's as quick as it takes to actually make the reading, which is very quick indeed.
So far, Professor Dafforn and his colleague Matthew Hicks have designed a machine that can detect a variety of one of the most dangerous bacteria, E. coli.
So, here it is. Well, that's it.
Yep.
But it looks so simple. So how does it work?
Well, we've simplified the test, and one of the key things for us is that it's easy to use.
Right.
So, why don't you take the sample?
The scanner uses light to see where the molecules are lined up or wrapped round each other.
And what's going to happen is the sample, as you inject it, will go through this flow cell. The molecules will line up, and the laser that shines through, so there's a laser, if we just have a look here. So the laser will pass through the sample differently if the molecules are lined up or if they're not lined up.
And that'll show on this display?
Yeah, so in this case, because there's no pathogen there, we're seeing a signal.
There's a very clear spike.
The graph is counterintuitive. If no E. coli are present, the viruses align in the flow of liquid, and some of the light from the laser is absorbed, which the graph shows as a spike. If E. coli are present, the viruses attach to the bacteria, forming clumps, and prevent alignment. Light travels straight through, and the graph shows a flat line.
We've gone from a lab full of sophisticated instrumentation and equipment run by dedicated scientists to something tiny on your tabletop. I mean, that is really impressive.
We've seen that it works in principle. Now let's put it to the test.
I'm on my way to the hotel I'm staying in, with dozens of people coming and going and food being prepared. A hotel is the ideal breeding ground for germs. So I've brought with me some of these. They're swabs for taking samples. Let's see if we can find some E. coli.
There are many kinds of E. coli bacteria. Some are harmless. Others, transmitted through contaminated food or water, can cause serious illness. We've commandeered the lobby to run the tests. Our first sample is from the hotel elevator.
I genuinely don't know if we're going to find any E. coli. So, Matt, can you run this sample then through your tester?
Yeah, let's have a look.
We're searching for one of the most dangerous strains of E. coli, called 0157.
Jim, why didn't you run that through the scanner?
Ingesting contaminated food or water can cause bladder infections, kidney failure, even death. Tiny amounts of 0157 could trigger a major outbreak.
And the good news is that we don't have it here.
So sample number 1 is negative?
Yes.
Okay, well let's move on to the next sample then.
It's from the door handle to my hotel room.
And we're all clear again.
In England alone, there are 30,000 cases of E. coli infection every year. The deadliest ever outbreak was in 2011 in Germany. 53 people died. But thankfully, the sample from this toilet is negative.
We've taken samples from across the hotel, and in a matter of minutes rather than days, it's given us the all clear. We haven't found that particular deadly bacteria. Where's this going next?
Well, the really exciting thing is the fact that we can develop this test for lots of different types of bacteria and viruses and other molecules, all at the same time within the same test.
So not just looking for this particular strain of bacteria, but things like SARS and MRSA?
Exactly. We've already seen that you can move this device around. But even more than that, we've got a prototype of a new device that's going to be even more possible.
It's an exciting thought. By re-engineering nature down at the molecular scale, what we can do for E. coli today, we'll be able to do for countless other diseases in the near future. A decade from now, it could be in hospitals, surgeries, and out in the field.
I am certain synthetic biology will be at the heart of our future. And not only will it transform medicine, I've heard how genetically modified microorganisms can be implanted into fabrics where they feed on human sweat, making clothes self-cleaning. Bolts of lightning are one of Mother Nature's most stunning tricks, transferring energy through space without the need for cables. We can do it with radio waves, so why not with electricity? Well, it seems like the same question occurred to some enterprising engineers in Boston. Karen and Bondar is ready to explore their surge of ingenuity. Have they invented a process that could transform how we will soon get our energy?
Electricity fascinates mankind. It's nature's most mysterious force. More than a century ago, a scientist had a remarkable dream for how to supply power to cities across the world. His name was Nikola Tesla, and in May of 1891, he brought this futuristic vision to life. Tesla allowed hundreds of thousands of volts of electricity to pass through his body without causing pain or harm. It was an early demonstration of high-voltage alternating current. Tesla proved that he could use AC to safely transmit power across great distances. It was one of the greatest scientific discoveries of all time. Although it can't be solely attributed to him, he championed the idea, and now AC surges through millions of miles of cable to supply our cities. But Tesla had an even bigger, more outlandish idea for another technology that he one day hoped to bring the world: to beam electricity through the air without any cables at all. Giant towers would fire electricity into the atmosphere to circle the Earth and bring energy to people thousands of miles away. Tesla's dream to change the world? One he never fulfilled. But perhaps it wasn't fantasy. The ability to transport electricity across open spaces with no cables would be a major scientific breakthrough. The question is, can it be done? It's a world engineers here in Boston are already creating by harnessing the mysterious power of magnetism.
First, we're going to start with what we call a source. Inside here is a coil connected to a capacitor. And when we plug this in, it will create an oscillating magnetic field around this object. So it's plugged in, and it's creating a magnetic field around this.
Okay.
What we've effectively done at this point is turned electricity into a magnetic field.
Okay.
Now if I take a coil and I place it here, I can now go over distance and I can change its orientation.
So the genius of this breakthrough is how coils inside the objects are designed to resonate at the same frequency. If they're within range, magnetic energy hops from one coil to the other, where it's converted back into electricity. To extend the range, simply add more coils to repeat the signal. Very little power is lost, and low-level magnetic fields pose no health risk.
So it's super safe, it's very efficient, and it works over distance. It also works through you.
Oh my goodness. So Tesla was right. It is possible to move energy through the air without using cables. And in today's power-hungry societies, this is going to change things day to day for the better. Chief Technology Officer Katie Hall claims I may never have to plug my cell phone in again.
Hi, Karen.
Katie's.
So here, let me give you the cell phone. You can see it's a usual cell phone, same size as ever. If you place it right down next to the computer, watch what happens. Isn't that great?
Excellent.
So we've got a wireless receiver built into the phone, and it's actually getting its power from the computer. And in this case, what we have, you'll see that we've got a source that's attached to the bottom of the computer, but that will be built inside. And then when you have your computer operating on your desk, you just put your phone right down next to it, and it's going to recharge while you're working on your computer. Well, let me show you another application that we're working on. One of the things we've done is to build the world's first wirelessly rechargeable AA battery. So you see it's the same shape and everything else. It's actually a little bit lighter than a regular AA battery. And what's built into that is a receiver for the wireless power and a rechargeable battery. And now you can put that right into the device that it's being used for. In this case, it's a little flashlight. And you see what happens is when I put it inside a bowl with a electricity source, it just starts charging. So all I have to do is throw things into this bowl and it's automatically recharging.
Okay, so when can I get my hands on one of these?
Well, we expect these to be commercially available in 2015.
Wireless electricity is going to change our lives in so many ways. Say goodbye to 40 billion batteries and hundreds of meters of cable in your home. And these guys are hard at work on the next generation of wireless electronic products. This car doesn't need gas, just 6 hours to charge. Best of all, no need to plug it in.
A prestige German automobile. Battery operated and wirelessly powered. Just imagine, by 2020, all cars could operate this way. Oh, and losing your cell phone charger. That will definitely be a thing of the past. Eureka. We've seen how science is tapping into nature's incredible diversity. From biomimetic robots and adhesive tape to helping us find solutions for asteroid attacks and disease outbreaks. The natural world will always be evolving, creating new, fantastic wonders we can benefit from. Sadly, one thing I'm fairly certain it won't ever give us is a secret to time travel. I'm still working on it. But since I haven't cracked it yet,